This conference will now be recorded.
Well, welcome everyone. Really appreciate you taking your time to be with us today. We're going to go over some of the products and principles of grounding and some products that ERICO offers. I am Melvin Silvey. I'm the North American National Sales Manager for the EDT division, the ERICO Data Telecom division of Invent ERICO. Oscar Martinez will be doing the latter part of the presentation. I've been with ERICO 20 and a half years. Oscar's got about half a year. So between us, we can hopefully figure out what we're doing and get you all started. But I want to thank you all for being here first and foremost, and hope everyone is safe and sound. Go ahead, Oscar. Just a little bit of ERICO history. ERICO was started in 1903 as the Electric Railway Improvement Company, hence the ERICO there, and it was originally started to do the signal bonds and related welding of equipment on rails. And as you can see from some of the pictures there, in 1903 and the early 1900s, these safety measures were a little different. And Oscar, we've lost the presentation. Okay, there we go. All right, why is grounding important? First and foremost, is for personnel safety. Oscar, or if everyone can mute their microphones, this reduce the potential difference between non-current and the earth. And the main thing you want to protect is your personnel. You want to keep your people safe. Then you want to protect your equipment because today's electronics are very sensitive, very expensive. So you want to protect that. You want to protect against lightning dissipation, electrostatic discharge, and noise, which is the noise emanated from air conditioners and generators, things like that. You want to protect against that as well. And over several decades of research and study, our engineers came up with a 6-point plan of protection for a facility. And this starts off with capturing the lightning stroke, which can be done many ways, from the old Franklin rod all the way up to a System 3000, which is an active system. Then you have to safely convey that energy to the earth, to the ground, through a very elaborate cable, or you can do it with copper or aluminum cable. And then you want to dissipate that energy into the earth through a point of ground rods, ground electrodes. And the one that's probably the most overlooked is all of them is bond all the points together. You want to make sure all the equipment on every floor is bonded together, and then all that bonds are connected to the earth ring itself. Then you want to protect all your incoming AC feeders, and you want to protect all the low voltage circuits, your data, your telecommunications centers. All that has got to be bonded together, and that's the very key point in the protection of a facility. And the products that Invent ERICO offers is we offer all the grounding products, from the ground electrodes, the ground enhancement materials, the Cadwell exothermic connections. We offer the traditional blue tube and the new Cadwell Plus. We feature all the bonding products, which are your mechanical connectors and ground bars. That we do the lightning protection, from what I've mentioned just a moment ago, from the Franklin rods to the third picture there is the active lightning protection system, which actually sends out streamers to capture the lightning strike. And then we also offer the surge protection products from the facility entrance all the way to the datacom. The difference in there's different kinds of connections for the grounding bonding system. Mechanical compression, you can see all the different ones there. We have a couple in there, the acorn clamp, the hammerlock. Then you have the compression type connectors. Then you have exothermic connections, which we will touch on in here. Copper and aluminum are your most commonly used conductors, with copper by far being the most common. The grounding and bonding, why do you ground? The grounding is a connection, whether it's intentional or accidental, whatever, that grounds all the metallic and electronic equipment to the earth. And bonding is the permanent connection of all these metallic parts one to each other. So bonding is actually the joining of all the parts together. Grounding is where the energy is dissipated into the earth. And I'm going a little bit quick. We've got a lot of slides to go over. So please interrupt me if you have any questions if I go too quick to make everybody understand. I apologize. All right, Cadwell. A Cadwell exothermic connection is a process that welds copper to steel or copper to copper. It's an electrical connection caused by an exothermic process. It's a chemical reaction that releases the heat. And by releasing the heat, it's 4,500 degrees Fahrenheit. And what you get is a true weld where your conductors, or your conductor and the steel, the conductor and the ground rod, it actually fuses them together. So instead of making a connection, you're eliminating a connection. You have one molecular bond where everything is welded together in a solid copper connection. It is permanent and it's irreversible. The original Cadwell came out in 1938. It was invented by Dr. Charles Cadwell. And all we did was drop the last L of his name, put a D to it, since it was a welding process. And what we did was it eliminated the one person having to take so much equipment onto a site. He was having to transport several hundred pounds of equipment to make this connection. And we cut it down to about 10 pounds of equipment. That includes the mold, the weld metals, the starters, everything. So we actually made it a lot safer, a lot easier for the person to do the connections. And we are the Coca-Cola Kleenex of the grounding world. You'll hear a lot of people say, hey, I made a Cadwell connection, when they actually might be using one of our competitors. But we are the synonymous with exothermic welding. We install it, and we have made over 100 million connections worldwide of Cadwell installations. Why do we Cadwell? There's no electrical power source needed. It's a very lightweight and portable, like I just said. It's a very quick process. It's a process that until you see it made, it's a simple process, yet it's a very technical process. And it's the only way to weld copper cable. And once you make this connection, once you Cadwell two conductors together, they have the same current carrying capacity. And so usually the connection does better than the conductor does. It is a permanent connection. It will not loosen or corrode, and it can be visually checked for quality, which is very important for the electrical inspectors. And this is a study that was done in Nevada. It's the National Electric Grounding Research Project. And you see the top two are probably the most two common connections for grounding a ground rod to a conductor is the acorn clamp. The third picture is a compression clamp, and the fourth one is the Cadwell. You can see from the top two pictures, this was buried in the ground for 10 years. And you can see from the top two pictures, there's a lot of corrosion on the acorn clamp. You can see on the second picture, you can see a lot of air gap there. That means that there's not a whole lot of surface area of the conductor, the clamp, and the ground rod. I think we estimate there's about 38% surface area contact. On the third picture there, the compression connector, you can see where all the oxidation has occurred, all the green, that is where moisture has gotten into the connection. And if you look at the Cadwell connection, you can see there is no corrosion. There's nothing at all there. The connection is still perfect. The Cadwell process involves the graphite mold. We use a very high dense graphite that will keep the heat in and will allow the connection to be made. The well metal, which is a mixture of copper and aluminum oxide. The reason for the combination is the aluminum oxide ignites at a lower temperature, and then the molten aluminum ignites the molten copper. Only the molten copper goes through the mold to make a solid copper connection. All the aluminum will remain inside the mold as slag. And the igniters, there's for their traditional blue tube, there's the flint igniter, and then we have the Cadwell Plus. The third picture there in the Cadwell Plus is the current control unit. That will be replaced by the one in the middle, which is a better, ergonomically better control unit. It will be replaced in the brick about mid-June. Another component is the handle clamps that are used for the mold. Anytime that a mold is bought, the handle clamps must be used. And the handle clamps are for making sure that the mold closes properly, that you don't have any leaks or spills of the well metal once you get that together. The cleaning tools, and very, very important, the life of the mold is but the keeping the mold clean. Once it is cleaned, you use the wire brush to clean the wires. You don't want to use the wire brush on the graphite mold because the wire will actually scrape away the mold itself, and you lose the integrity of the mold. And then we sell the separate sleeves where if your own site, you got the mold that you happen to have with you does not fit the exact size cable you have, you can insert sleeves over it to where it will fit inside the mold. And each one of the molds comes with that brass plate on it. Go back one, Oscar. The brass plate that you see on the graphite mold, what is on that brass plate is it tells you the part number, what size conductors the mold is for, tells you what well metal to use. So that is on every single mold that we send out, that brass plate. And the blue tube, the old traditional Cadwell process is once the conductors have been placed in the mold closed properly, you insert a disc, the well metal pours in, and then at the bottom of the tube is a starting material, which is the same well material. It's just ground much finer. You have to tap the tube, pour some into the well metal and some on top of the mold. You use the flint igniter, which is about 6 inches from the spark. It's about a 500-degree spark to ignite the well metal, and then that will ignite the aluminum. The aluminum ignites the copper, and then as you see, as you open the mold, you have nothing but a solid copper connection of the conductors. The Cadwell Plus process is a much safer, cleaner process. The well metal comes in a cup, looks much like a Keurig cup, and it has the igniter strip on it. The same process, you close the mold with the conductors in it. You drop the well metal cup in. The strip inserts into the leads of the control unit. Then you press a button for about 5 seconds for it to build a charge, which is a built-in safety feature. When you're making the connection, you don't want to accidentally bump the start button and it go off and ignite the well metal. So that is a built-in safety feature where you have to hold it down for it to build a charge. Then it ignites the well metal, and you have the same connection as you do with the blue tube. But you can be 6 to 15 feet away from the connection, from the ignition, instead of 6 inches. And then the OneShot has been around since 1959. It is exactly what it says it is. It's used one time. This is very widely used in the telecommunications industry. It's usually for a ground rod to a conductor, and the body is ceramic. It is not made out of graphite, so it is used one time, and then you can either break the mold off or just leave it on, whichever one the electrical inspector prefers. And the ignition systems, like I mentioned previously, was the flint igniter, for the traditional Cadwell and the control unit for the Cadwell Plus. Excuse me. The tools and accessories are the handle clamps, which is very important for the handle clamps because we've had several instances where we have been called by contractors, by end users, where they were having issues, where they were having leakage. And a lot of the time they were not using the handle clamps. They were used, as you can see in the picture there, there's a clip that comes with the mold. That clip is for shipping and storage purposes only. That is not to hold the mold in place for making the connection. So the handle clamps are very important. We have several different kinds. The most common is the L160. We also have the chain clamps whenever you're grounding, especially like at a cell site where you're grounding each one of the posts to the ground ring. The chain goes around and holds the mold to the post and make the connection. When you're grounding to a flat steel surface, we have the magnetic handle clamps, which are at the bottom left. That will holds the mold to the steel surface, and then you make the connection. The tools accessories are the flint igniter for the traditional. We sell the replacement flints, but the tool itself is so inexpensive. We just usually sell the tool when someone needs one. The plus control units, the one on the right is the one that is available right now, the plus control unit. The new one that will be coming out the middle of June and will be in inventory is the plus CU2. It is much more ergonomically correct. It's much safer. It utilizes both the 8 AA batteries that come with it, or you can buy an adapter plate for a Milwaukee or an adapter plate for a DeWalt cordless battery. And then we also sell the replacement leads for those as well. This is just a quick view of the new Cadwell Impulse Control Unit. It's safety. It has the safety guard on the trigger, where if you can't bump it, you have to flip the trigger guard up to press down on it. The power, we have, like I said, we have the 3 types of power: the Milwaukee, the DeWalt cordless batteries, or you have the 8 AA batteries. The ignition light, when you depress the trigger, the Invent logo there will light up, and when it gets to the last one, that's when it's built to charge up and will ignite the connection. And like I say, the batteries, it comes with standard with 8 AA's, or it comes with the adapter plates for a Milwaukee or a DeWalt cordless battery. And the cables are heat sensitive. It doesn't matter which way you plug them into the unit. You can't reverse the polarity. The clip on it has a viewing area where you can actually now see that the igniter strip has been inserted into the clip, to the leads, and you will make a proper connection. And Oscar, well, before we go any further, I went quick there because we do have a lot of slides, but does anyone have any questions on Cadwell? Okay, well, Oscar, you may take over.
Thank you, Melvin. Well, ERICO, good morning to everybody. My name is Oscar Martinez, and as Melvin said, I've been with the company for less than a year, but I'll try my best here explaining a little bit more of ground rods and grounding systems. ERICO, it's has provide ground rods for long years, for many years, and it's been the biggest producer of ground rods in the world. So the ground rod basically is the point of exit or dissipation of all this energy captured and bonded together and transmitted through the facilities or equipment to the earth. What we can see here is how this energy is dissipated into to the ground. It's equivalent to the roots of a tree, and the more you get away from the point, from the center, when the ground rod is driven, the less the voltage is dropping until it gets all the way down to zero.
Yeah, good one. Can you hear me?
Yes.
Yes, a good way to think of this here is how the energy is dispersed into the earth. Is if you stand on the side of a calm lake and you throw a rock into the lake, where it hits the water, the waves are the strongest, the biggest, and as it gets further away, they get smaller. That's the same way the energy is dissipated to the earth. At the point of contact, it's the strongest, and as it gets further away from it, it gets much weaker.
Now, the most common ground rod is the copper bonded steel ground rod. And against or compared to the galvanized rod, the advantages are because of its corrosion properties, life expectancy, and the UL requirements. We can see on this graph here that if we use a copper bonded steel with a cover of 10 mil copper, the life expectancy is about 35 years. When you go to 13 mil, you can increase about 10 more years of life expectancy. But when you switch to stainless steel, you can go up to 50 years. The thing is the cost. Obviously, stainless steel will cost probably more than getting the copper bond steel 10 mil replaced after 35 years. So you will get more with copper bonded steel with 10 mil. Now, a new product, well, not a new product actually, have an updated part of the product, but the product has been in the market for utilities is the Hammerlock. And basically with this old new 5G era we're starting now, the increases of small cells around the cities, it's going to be rapidly, and they're going to be fast deployments and probably a lot of small contractors. And basically what happens is with all these people when it's not trained by Cadwell on Cadwell on exothermic welding, we need something fast and easy to use with these people or these contractors to make the grounding correctly. So we came up with the Hammerlock, which will go on top of the ground rod, and basically it's a mechanical connection with a piston that will connect copper. It's made all the copper and will connect the ground wire, and it will do a permanent connection to the ground rod. Now, all these carriers are looking for four different type of configuration for the ground rods. So the first one is when you get two ground rods in line, trying to get the 25 or less ohms. And if you cannot get that, you can use the triangle version, which AT&T likes a lot. And if the space, because these small cells doesn't have much space for it, doesn't allow you to go in a triangle or on two ground rods in line, you can do the inverted V, which is the third picture down in the bottom. And basically what you do is drive the ground rods 45 degrees to get more space cover on below grade, and you connect the two ground rods to the ground wire and to equipment, to the antenna and transmission equipment, and you can get lower resistance. And for different types of soils, I guess it's not that common method, the most common method here in the United States, but you drive two or more ground rods deep and try to get the 25 or less ohms there. Now, basically, the Hammerlock will solve the rapid deployment when needed, right? It creates a permanent connection for these small cells, and cannot use Cadwell for any reason. And the benefits that we have is it is an all copper connection. And because of not dissimilar metals, you'll get basically low corrosion exposure. I mean, if you see the third picture on the bottom, you'll see how the ground wire and the piston and the hammerlock, which is all copper, connect just basically as just one body. And there's no special training needed, no special tooling, or even it's a quick and easy installation. You just need a hammer and drive it down to the ground. Now the parts of the hammerlock, I'll talk about the piston, but how it works, you got the ground rod hole, so you place the hammerlock on top of the ground rod. You try to get the ground rod driven by knee high or a little bit higher, so you can have enough room because you're gonna start smashing the top of the hammerlock trying to get the connection. While you're doing that, you also are going to be driving the ground rod into the ground. And then you got the ground wire hole where you get the ground wire pass through to make the connection, and the top of the piston. And the top, sorry, the piston. Now, when you're smashing the piston, you can go you won't go more than needed. I mean, it just, when it sits there and you see the first edge of the piston, when it sits there, it won't go any further. So you won't damage the connection because you smash it too hard or you smash it too much. I mentioned some of this already, but the features of the hammerlock is an all copper connector, which its benefit is minimize the corrosion. It is a very simple installation, as you saw in the pictures. There's no special training needed or tooling. It is UL listed, so it's approved for direct burial. And I know with the compression connections, you need to work on the ground rod pre-crimping. You need to prepare the ground rods. So in this case, you don't need to spend any time on that. So you go directly to apply the hammerlock on top of the ground rod and drive it. Now, which is one thing that is really important is the hammerlock will fit tight on the head of the ground rod, on the top of the ground rod. So we have to be really careful not to mushroom it or damage the head while we're driving the ground rod into the ground. Therefore, we will need either a ground rod driver or a ground rod driver sleeve if we're doing just a hammer. And then if we're using power tools or rotary hammer, we also sell the ground rod drivers for rotary or power tools. So the ground rod doesn't get damaged or mushroom, and then the hammerlock will fit perfectly. In summary, well, it is a great alternative to Cadwell. It is useful in really widespread applications. You don't need to train the personnel to use it, and you will get a very good electrical and mechanical connection. Now, for gem and QuickFill are ground enhancement materials when the space is short or the type of layout is complicated to help us get lower resistance. We use what we call gem, which is a ground enhancement material. It's a cementitious conductive material, and it's environmentally sensitive solution for this to lower your resistance, does not dissolve, decompose, or leach out, which as a consequence, you get like type of a theft deterrent safety here because it will protect your ground rod and your connection. It is ideal for areas of poor conductivity, I mean, rocky ground, mountain tops, or even sandy soils. Improve electrical connection directly between the conductor and the soil to dissipate the energy. And that's a consequence because it minimizes the ground resistance. And also, this will promote protection against corrosion because the gem will absorb most of the moisture generated close to the ground rod or the connection, and it will help on that. And it's easy to use. I mean, you can get the fully set within 3 days because you need to wait to cure the cement part of it. This is an example of a picture, example of how it's prepared and pour. It's really easy. I mean, you just need the mixer, the jam, and water. You mix it together, and then you can use it on a trench or whenever you are making the connection. Now we have QuickFill. The difference with QuickFill is it's a product ready to use, and also it's a low dust product. So when getting the product, getting to the site is complicated, getting water there, material complicated, QuickFill could be a very good option. It could be installed below freezing temperatures because it doesn't need any liquid in it. It's fast and easy to install. And you can get your measurements of resistance taken immediately after installation. Excuse me. Now, the applications, it's where low dust and cleanliness is really important. When fast installation, it's really critical, like a small cell application, street enclosure, even a cross-connect cabinet. Remote location where cement mixing equipment or water is difficult to transport, like on top of a mountain or on a cell site really far away from everything in the middle of nowhere. QuickFill is a good solution. And it's easy to be moved from site to site. Now, this is a comparison between gem and QuickFill. The gem has carbon and cement. The QuickFill is just carbon, and the resistivity gem will get you better resistivity per centimeter than QuickFill. Both has passed the leaching test. But QuickFill is low dust, so you don't need to use a dust mask if you don't have to for the site to pour the product. But when you use gem, you should use a dust mask. And the installation, QuickFill is really fast to install. It will take you just the time that you need to pour it inside the trench, and that's it. Could be less than a minute. Then gem, you need to prepare it with water, mix it, and then pour it. So it would take more than 5 minutes, a little bit over. QuickFill doesn't need water. And the cure time on QuickFill, you got immediately. I mean, it's already, once you pour it, it's already done. Then gem, you need 3 days to partially be cured. Gem does offer fat deterrent benefits. QuickFill doesn't because it's loose material and resists seasonal variability. QuickFill doesn't show. Gem, yes, resists seasonal variability. These are the visual difference when you're using QuickFill against gem. And at the bottom, you got the end of the pouring to protect the connection pictures. When on the right, you got the gem waiting to cure. On the left, you got the QuickFill all ready to be measured. If you need any more information, you can go to ERICO.com. You can look all the information about what Melvin was talking about and I was talking about. You can go and get your part number for your mold, part number for your Hammerlock if you need to. You just go there and follow the instructions, and it's really, really easy to use. For any assistance or more information, you can contact directly Melvin or myself. Here are our emails and phone numbers if you need to contact. Well, thank you for your time, and I see we have some questions there.
Yeah, one thing I wanted to mention, and I should have done this, is all our products are made in the USA. The ground rods are manufactured in Aberdeen, North Carolina, which is a suburb of Pinehurst, North Carolina. The Cadwell and the Hammerlock are manufactured in Ohio, and the majority of our connectors are made in St. Louis. So that's one thing I did want to add in there, is we are a USA manufactured company. Does anyone have any questions?
Melvin?
Yes.